This is section 6.2, equations as relations. Okay, so before in the last section we were talking about relations being like an ordered pair, whether we saw it in like, a parentheses group or if we saw it in a table or a graph, those were all relations. Okay, so now we're going to move on to equations dealing with those relations. So now what we're going to deal with is equations in two variables. So before, when we dealt with equations, like we had something maybe in here for the y, so like maybe like 5 is equal to x plus 1, and then we could solve that for x. But now what we're going to do is we're going to be dealing with where we've got two different variables there, an x and a y, like our ordered pairs, where you plug one value in and get the other value out, and then that would be on your graph of this equation. Okay, so a solution set is ordered pairs that work in the equation. So if I took each one of these ordered pairs and plugged them in, so like -1 for the x and 0 for the y, so if I do that, 0 for the y, -1 for the x, plug it in to those two spots there. If I did -1 plus 1, I would get 0. 0 equals 0, so that checks out. That would work for that. So all of these values listed here all work when I plug them into those equations there. So that would be a solution set, okay? Points that actually work in that equation. Okay, so what they want us to do here is they list out some ordered pairs for us, and we have to plug them into this equation and see if it comes out to work or not. If it works, we put yes or true, either way, and if it doesn't, you put no or false. Okay, so here in my table, I'm going to list out my ordered pairs. So I've got 0, 0, 1, 4, 2, 1, and -1, 2. Okay, so now what I want to do is I want to take these values and plug them into that equation there, so y equals -x plus 3, and see if it comes out to be true or not. So here, my y value is going to be 0, and my x value is going to be 0. So I'm going to go 0 for the y is equal to negative, and then I've got my x value there, which is in the first position of 0, plus 3. Okay, so here when I look at it, this would be 0 is equal to, and then negative times the 0 is still just 0, and then plus 3. So 0 is equal to 3. Well, I know that's not true. So that would be no or false. Try the next one there. So 1 for the x, 4 for the y. So my y is going to be 4 is equal to negative, and then my x is going to be 1 plus 3. So here this would be 4 is equal to -1 plus 3 is 2. So 4 is equal to 2. That doesn't work either. Next one here, I'm going to try 2 and 1. So my y is 1, and my x is 2, so negative, and then my x value, which is 2, plus 3, so that would be 1 is equal to -2 plus 3 would be 1, so 1 is equal to 1, so that one does work out because it's the same on both sides, so that one would be yes or true. And then my next one here, -1 for my x, 2 for my y, so 2 is equal to negative, and then since it's a -1 there, it's basically a negative times a negative, which we know ends up being positive. And then plus 3, so that would be 2 is equal to 4, which does not work out, so that would be no. So in some of those situations, you might have more than one answer, so you just have to go through each of them and figure out if it's yes or no. Okay. Next one here. So this one is kind of similar to what we had before. The only difference is instead of giving us ordered pairs, what they do is they just give us a domain value. We know our domain is going to be our x values. So basically what they did here is they just listed out x values that they want us to plug into our equation here, y equals 2x plus 1, and figure out what our y values is to get what our y values are to get ordered pairs that match this. Okay, so I know my domain, or all my x values here, are -2, -1, 0, 1, and 2. And then what I'm going to do is I'm going to take those values for x and plug them in and solve for my y. So I'll have y is equal to 2, and then for my x, I'm going to plug in a -2, and then plus 1. So here I would have positive 2 times -2, which would be -4. Plus 1 would be -3, so my ordered pair, my x, since that's what they gave me, is negative 2, and then when I solve this out for y, I get negative 3, so my y value would be negative 3. Same thing again, I'd go y is equal to 2, and then this time my x value I'm plugging in is negative 1, plus 1, so that would be 2 times negative 1 is negative 2, plus 1 is negative 1, so my ordered pair this time is negative 1, negative 1. Next one I'm going to plug in is 0. I usually like plugging in 0 because usually it's pretty simple. So it would be 2 times 0 is 0, plus 1 is 1. So my ordered pair here for my x is 0. My y, when I do it out, it would be 1. And I plug in my 1. So 2, 1 for the x, plus 1. 2 times 1 is 2, plus 1 is 3. So 1, 3. And then the last one there, y is equal to 2, and then 2 for the x, plus 1. 2 times 2 is 4, plus 1 is 5. So 2, 5 for that ordered pair. Okay, so then what I do is I take and I graph those points. So I've got those points listed out there. I can just take and graph. So like negative 2, negative 3, I would go left 2 and down 3. Negative 1, I would go left 1 and down 1. 0, 1, I would go over 0 and up 1. 1, 3, right 1, up 3. And 2, 5, right 2, up 5. Now, anytime you graph these equations, it should always come out to be a straight line. And what we want to do here is we actually want to draw that line in like that. And you don't have to use like a ruler or anything like that. You can just kind of eyeball where it's going to be there. But you want to draw a straight line through those values if we're dealing with equations. Okay, next thing here. So it's kind of similar to what we had before. The only issue here is we're not set equal to one of our values. So like with this one, let's flip back to it. We had our equation y was equal to everything else. So then when we plugged in, it would just kick out a y automatically. Here we don't have that. We have 6x plus 3y is equal to 12. So what we want to do here, since we're plugging in x values again for domains, so those domain are going to be our x values, we want to solve this for y. Okay, so we have to go back to what we know about equations. And what we want to do to get the y by itself is we want to start by getting rid of the 6x. To do that, we're going to subtract 6x from each side. So then that's going to go away, and we'll have 3y is equal to negative 6x plus 12. And then to get rid of multiplying by 3, we're going to divide by 3 on each side. So then I would have y is equal to, if I do negative 6 divided by 3, that's negative 2x. And then I have to also take the 12 and divide it by 3, which would be 4. Now this equation here, y equals negative 2x plus 4, is going to be a lot easier for me to plug in my x values and get a y out. Okay? Okay, so my x values here are my domain. So you can put an x there if you want. And then we've got negative 3, negative 1, 0, 1, and 3. Our equation that we just came up with here was y is equal to negative 2x plus 4. And then we're trying to come up with our ordered pairs there, which are our x and our y's. Okay, so same as before, these are my x values, or my domain, so I'm going to take those guys and plug them in. So y is equal to negative 2, and then instead of the x, I'm plugging in what I know my x is equal to, so negative 3 plus 4. So this would be negative 2 times negative 3 would be it would be positive 6, and then positive 6 plus 4 would be 10. So negative 3, 10. Next one there, I plug in negative 1, so y is equal to negative 2. My x value is negative 1 plus 4. So negative 2 times negative 1 is positive 2, plus 4 is 6. So negative 1, 6. Plug in 0 here, which is my favorite one. So negative 2 times 0 plus 4. So that would be 0 plus 4 is 0. So 0, 4. And then I'll have y is equal to negative 2, and then my x value is 1 plus 4, so negative 2 times 1 is negative 2, and then plus 4 would be 2, so 1 for the x, 2 for the y, and then last one would be 3, so negative 2, and then I'm going to plug in a 3 for my x, plus 4. So that would be negative 2 times 3 is negative 6, plus 4 would be negative 2. So 3 for my x, negative 2 when I solve out for my y. Okay, so then I just take those ordered pair values and graph them. So I would have negative 3 tens, so left 3 and up 10. Negative 1 6, so left 1, up 6. 0 4, so over 0, up 4. 1 2, so right 1, up 2. And then 3 negative 2, so left, or not left, right 3 and down 2. And again, those should make a straight line. So you'll want to shoot a line through those. And then you also always want to put arrows on both ends because those lines can go in both directions forever. Okay, next thing here. So this one is slightly different because they actually want us to find the domain or the x's this time, and they give us the range. So here, instead of giving us the x's, they actually give us the y values. Okay, so what I would want to do in a case like this, since it's kind of opposite what we had before, is I would actually want to take here and solve for the x, because when I solve out, I want my answer to be what x is equal to, instead of having it equal to y. So if we are given the range, we actually want this to be x equals when we solve out. So what I'm going to do is I'm going to take that equation, so y is equal to negative 3x, and I'm going to solve this for x. Okay, and you don't have to, it just makes it a little bit easier when you solve. So here, to get the x by itself, I would divide by negative 3 on each side. So what I would do here, you could either write this as y over negative 3 is equal to x, or negative 1/3 y is equal to x. I think instead of dealing with multiplying by a fraction, it's just as easy to divide by a negative 3, so I'm going to use this equation when I do my plugging in here. And now you need to be very careful because this says range, right? So instead of our x values that we were doing before with domain, now we're plugging in y values. So here we're going to have y's for our range. So negative 6, negative 3, 0, 3, and 6. And then we're going to use this equation here that was x is equal to, and then y divided by negative 3. Okay, and I'm just doing that backwards because I'm given the range instead of the domain. Okay, and then we'll write our ordered pairs out the same here, x and y. Just be careful, your y values here are what's listed first, so just be careful when you write these out that you put your y value at the end. Okay, so then I'm just going to plug in and solve these. So x is equal to, these are all y values, so negative 6 is going to go for the y, so negative 6 divided by negative 3. So if I do that out, negative 6 divided by negative 3 would be a positive 2, and that's going to go in my x position because I'm solving for x here. Okay, and then my next one, x is equal to, my y is negative 3 over negative 3. So if I take negative 3 and divide by negative 3, I get 1 for my x value. So 1 and then negative 3 for my y value. Next one I do is 0, so x is equal to 0 divided by negative 3. So 0 divided by negative 3 is 0, so this ordered pair is 0, 0. So 0 for the x when I solve out, and 0 for the y. Next one would be my y value is 3 over negative 3, so 3 divided by negative 3 is negative 1. So my x value here would be negative 1, and my y value would be 3. And then the last one here, x is equal to 6 over negative 3. And if I do 6 divided by negative 3, that's negative 2. So it would be negative 2, 6. Okay, so then for this one, it doesn't ask us to graph it or anything or come up with the ordered pairs. What it asks us is for our domain values. So here, our domain values would be what's in the x position. So we just write out all those values that we solved out for in the x position. So 2, 1, 0, negative 1, and negative 2. So just always be careful with those to see what they're actually asking for. Okay, so sometimes when they do these out, they're not always going to use the letters x and y. So if they ever use any numbers other than x and y, what we do is the variable that comes first alphabetically is the domain. So in this case, they don't use x and y, they use a and b. And so since a comes first in the alphabet, a would be the domain and b would be the range. Okay, so it's just like if I did like c and d, c would be the domain and d would be the range because c comes before d in the alphabet. Okay? Alright, so last one we've got here is an example that's actually in the book on page 247. So let me read that to you. So it says the equation 2w plus 2l is equal to p. So I'm going to write that. 2w plus 2l is equal to p can be used to find the perimeter p of a rectangle. So they've also got a picture there of a rectangle where they've got W, L, W, and L. Okay, so it says suppose a rectangle has a perimeter of 48 inches, so we know our perimeter is going to be 48 inches. And it says find the possible dimensions of the rectangle given the possible domains. Okay, so for our domain, they give us the values, what do they give us? 3, 4, 8, and 12. Okay, so we basically want to come up with the range values. Okay, so here, when we are doing this, we're using the letters L and W. So L comes first in the alphabet, so our L is going to be our domain values, because that comes first in the alphabet. And our W is going to be our range values. Okay? Alright, so if they give us domain values here, basically we're going to be plugging in for L. So what I would probably want to do here is I probably want to solve this for W since I'm trying to find the range values. So I'm going to solve this equation here for W. So I've got 2W plus 2L is equal to, and instead of P, I'm going to actually plug in that perimeter value, which they told me was 48. Okay, so now my goal here is going to be to solve for the W because I'm looking to solve for range values, which my range is going to be W. So I'm probably going to want to subtract 2L from each side. So then I'd have 2W is equal to negative 2L plus 48. And then to get the W by itself, I'm going to divide by 2 on each side. So I'd have W is equal to negative L plus 48 divided by 2 is 24. Okay, so now I'm going to take that equation, W is equal to negative L plus 24, and I'm going to put that in my middle part of my chart. And the values they give me for the domain are going to be my L values. So I'm going to have 3, 4, 8, and 12. And my equation is W is equal to negative L plus 24. And then when I solve these out here, my L is going to be listed first because that's like my X or my domain. And the W is going to be listed second because that's the range or my Y values. Okay, so now I just plug in. So W is equal to negative, and then my L value here is 3 plus 24. So negative 3 plus 24 would be 21. So 3, 21. Next one here, W is equal to negative and then 4 plus 24. So negative 4 plus 24 would be 20. So 420. Next one there, W is equal to negative and then my L is going to be 8. So negative 8 plus 24. So that would be 8 and then negative 8 plus 24 is 16. And then my last one, W is equal to negative, my L value is 12 plus 24, so negative 12 plus 24 is 12, so 12, 12 for that one. Okay, so then my answers for that for my range would basically be the 21, the 20, the 16, and the 12. Okay, so your book page assignment is page 248, 12 to 36 even.